Karibu SolidWorks Tanzania. Huu ni mwendelezo wa series yetu ya Industrial Automation, PLC Programming on Siemens. And today tunaenda kufanya two simple projects using PLC network. So let's see a condition that we have here and see how we go about it. So this first example ni on signal lamp control. So the statement says a signal lamp is required to be switched on if a pump is running and the pressure is satisfactory, or if the lamp test switch is closed. Right? So tuseme labda kwenye warehouse ama kwenye kiwanda ama kwenye plant kunakuwa kuna signal lamp. Signal lamp labda ni green lamp, green light, alright? Ama inakuwa ni inawaka kama a rotating lamp, okay? Inamaanisha kwamba hii taa inatakiwa iwe on kama pump is running, pump inatembea and the pressure is satisfactory, na pressure ambayo iko set iko satisfied. So let's see here. So what's the objective here? So the objective here is a signal lamp should be turned on under the following conditions. Condition number 1 ni end logic, kwa sababu wamesema pump lazima inatembea lakini na pressure pia lazima iwe satisfactory. Let's say tunapata input kutoka kwenye signal ya pump kwamba the pump is on, is running, the pump is running. Sasa tuseme pump labda inasukuma, tuseme ni pump ya maji ama ni pump ya oil. Alafu pia na wakati inafanya pumping, is the pressure satisfactory? Okay, sawa, tuna pump maji. What's the pressure? Let's say kuna pressure gauge ambayo inasoma kwamba let's say if the pressure is, let's say 1 bar, okay? Then if the pressure is at least 1 bar, then switch on. So that's a satisfactory pressure. Maybe that's just an example. So tutakuwa tuna end logic ya kwamba pump is running, input 1 pump is running, alafu input 2 pressure is satisfactory. If any of those is not satisfied, tuseme kama pump is running, pump iko on lakini pressure haijafikiwa, signal lamp haitawaka. Okay? Or secondly, lamp test switch is pressed, kwamba ile lamp yako ambao sasa inakupa signal kwamba everything is running okay, inakuwa na manual switch. Hiyo manual switch ukipress, let's say it's a normal open switch, then you can push it to, you can switch it on, so the lamp will be on, or switch it off, the lamp will be off. So that has two states. So you see we have an end gate of the pump and the pressure, and then odd or paralleled to the switch, then we have a lamp. So let's come to our TIA portal and say this project was called what? So let's give it the name of the project, say signal lamp control. So let's write here signal lamp control. Okay, so then tunaanzia kwanza kwenye show all tags, tunaanza kwenye tags. So tag namba 1 ni pump running. Okay, hiyo ni input namba 1. Digital input ya kwanza, pump is running. Digital input ya pili, pressure is satisfactory. Pressure satisfactory, like this. Those are the two conditions that should both be met to give the signal lamp. Ama we have a switch, so let's say lamp switch ambao ni digital input na yenyewe kwamba if you switch on with the manual switch, then the lamp will also be on, or switch off will be off. And then on the output we have a signal lamp. Signal lamp. Okay, so signal lamp hapa we have to change the address, is boolean yes, high or low, but this is Q for output, Q 0.0. That's the address of our output. Okay, after everything here is fine, go back to the main. So let's create our network. So here we have normal open input for the pump, input for the pressure, we have the output for the signal lamp, but then here we have a parallel switch, um, like that. Okay, so here we have a pump running, and here we have pressure satisfactory. Here we have a switch, and then sorry, this is a lamp switch, and then here we have a signal lamp, like that. Okay, so this signal lamp will be on if and only if the pump is running and the pressure is satisfied. If only the pump is running and the pressure is not satisfied, the signal lamp won't be on. Or the lamp switch is pressed, then the signal lamp will be on. Okay, so let's compile this. Let's come here on online, say start simulation. Okay, so we toggle the inputs and see if it's acting right. Maanake sasa aka ka network ndo ambako sasa kanakuwa downloaded kwenye hiyo PLC controller yako, alafu kanakuwa kanapokea input kwamba input kutoka kwenye pump kama iko on ama off, na input kutoka kwenye pressure gauge kama iko at the desired level or not, and then output inaenda control the lamp. So consider as trusted. Okay, load. Okay, here we say start module, finish. All right, and then tunakuja hapa kwenye download to device, so consider as trusted agent, load, finish, and then tunakuja hapa tunasema go online. Okay, if everything is green here, everything is good, say turn on monitoring. All right, ili tuweze kutoggle our conditions here, tuna click here. Okay, tuna click here. Let's wait for it. All right, then here tunasema new project. Let's say this is practices. Let's name this practices. Let's save it to downloads, then say create. Okay, let's wait for it. Okay, let's go to sim table. Here's a sim table. All right, see your load tags. Okay, like this. So let's toggle this. So let's say first pump running. Let's say toggle this. So the pump is running. So you see the pump is running, but the pressure is not satisfactory. So the signal lamp is not on. And then if the pressure is satisfactory, like that, so you see pump is running, pressure is satisfactory, so the signal lamp is on. But also if these are off, but we just lamp switch to switch, so you see if the lamp switch is on, then the signal lamp is also on, regardless of a condition here, if one is on or all off, etc. Okay, so I hope you have captured that. That's well done. Okay, so let's go offline. Right, so let's see another simple practice here. Okay, so let's say a safety alarm system using a set reset logic. So we'll see what's a set reset logic, right? So it says this is the problem. A factory system must activate an alarm. An alarm must go on if any one of the following hazardous events occur. Overheating detected. So kutakuwa kuna overheat detector, labda ni temperature sensor, right? Gas leakage detected. So kutakuwa kuna gas leak detector. Okay? Overheat detector inaweza kuwa ni sensor. Gas leak detector inaweza kuwa ni gas sensor. Unauthorized access detected. Let's say someone has entered the thing unauthorized, okay, ama amejaribu kuingia kwenye HMI ambayo ni human machine interface ya plant fulani ama ya process fulani, anajaribu kuswitch guess password, kwa sababu hizi PLC ukienda kwenye HMI sio kila mtu anakuwa na access na HMI, only the authorized personnel ambaye anakuwa anatoa login detail, labda name and the password. So akiingia mtu ambaye hausiki, ambaye anaweza kaleta madhara kwenye uendeshaji wa process fulani. Kwa mfano mtu anaweza akaja akaingia akaadjust parameter, labda unakuta let's say we are mixing chemicals, mwingine akasema okay, akaingia kwenye HMI akaedit labda chemical fulani sio kwa kiwango fulani, chemical fulani kwa kiwango fulani, unaona ina affect the output. You will not get the desired output at the end kwa sababu someone has altered the parameter. So kuzuia hiyo kunakuwaga na protections kwamba sio kila mtu anaweza kuaccess HMI au sio kila mtu anaweza kudownload ile logic PLC program ambayo iko stored alafu akaimanipulate. So lazima awe authorized. So kukiwa na any unauthorized access pia inataka wanataka isignal an alarm. So anasema once any of those input is triggered, either there is an overheating or there is a gas leakage or there is an authorized access, the alarm must stay latched on. Lazima iendelee kuwa on mpaka iwe resetted. Right? The alarm should only turn off manually when a reset button is pressed. Kwamba bwana, hii alarm itakata pale tu ukireset. Ukibonyeza reset button. Okay, so let's back here. Let me delete this. And now let me go to the show all tags. Let me change these things here. Let me delete this. Let me rewrite the inputs. So let's say the first input here is a temperature overheat detector. Ama inaweza kuwa ni temperature sensor. Then input ya pili itakuwa ni gas leak detector. Ama gas leak sensor. Alafu na input number 3 itakuwa ni unauthorized access. Unauthorized access. Okay, someone is trying to trigger the inputs. Okay, ama parameters. Then output yetu hapa ni nini? Output yetu ni alarm. Right? Alarm. Inaweza kuwa na alarm, inaweza kuwa kuna light signal lamp pia, etc. An alarm is fine. So here is what we have. So an alarm here is an output. So this is Q0.0. The rest of the others are inputs, right? Correct address. So we go back to the main and now we create our network. So here we have first we have overheat detector ama temperature sensor, and then parallel to heat we have, we close it, we have gas leak detector, and then parallel to it we have close it, we have unauthorized access. And now where do we get a set reset block, SCR block? So ukija huko to the very right utaona hapa kuna kitu inaitwa instruction, testing, task, libraries and add-ins. So tutatumia sana instructions and technology next. So on the instructions unaona kuna bit logic instruction, unaona tutaona many of these. Kuna timer operations, on delay timers, off delay, etc. Unaona hapa kuna counter operations, up counter, down counter, etc. tuna comparator, less or equal, greater or equal, less than, greater than, etc. Tuna math functions, kuna calculate, addition, subtraction, multiplication, etc. Tuna move operations, we will see how move operation works. Okay, kuna conversions, etc, etc. If you come here to the bit logic, you see there is this called SAR switch. So this is a set reset flip flop. Okay, so it sets or resets the bit of a specified operand based on the signal state of the input S and R1 ambao ni reset. Unaona before tulikuwa tunafanya latching manually kwa kucall again the output on the input, then tunakuwa tumelatch, tunaweza kuwa tuna press push button, tukirelease still ina hold the contact. But here set reset manake set is set reset block. If you activate set, then the output will be on. Unless the output is resetted, it stays on. So drag drop this block here. Okay, it's like that. All right. And this one is a SCR block. SCR block. So SCR block is a memory. So we go back to the, let's say this is M0.0. Okay, so I think I told you earlier kwamba kuna kuwaga na I for input, Q for output, M for memory, right? Memory na hold conditions temporarily. So hii SCR block lazima to hold the condition on this temporary memory, which is M, ina hold digito high or low. Umeona? Kuna MW na MD zenye zina hold maybe numbers, reals, integers, etc, etc. Hii M yenyewe ina hold bool memories. Unaweza ukarename from here hii tag ukasema hii ni SCR block. Okay, then ukasema hapa change. So SCR block iko hold on the memory, and then now you see all of these three inputs goes to the set. Then hapa tutakuwa na output yetu like this. Then we should have a reset switch, right? A reset switch. So here tutakuwa tena na here tutakuwa na extension like this, then a reset switch, then reset switch yetu itakuja up to here. Hold it, drop there, right? Okay, so so hii tunahitaji, hii tumesema ni safety alarm system, alright, safety alarm system. And then hapa tumesema this is a I0.0 ambao I0.0 ilikuwa ni overheat detector, then we have I0.1 ilikuwa ni gas leak detector, then we have I0.2 hiyo ilikuwa ni unauthorized access, and then here we have a switch I0.3 ambayo ilikuwa ni okay. I think I didn't put this on show, so go back to show all tags. Naona hapa sikuweka input ya control switch, so hii hapa nitairename. Hii hapa ni reset alarm switch kwa sijaiweka, so nimeipa address I0.3. Okay, go back to the main, itakuwa pia hapa imebadilika. Ningeweza nikarename tu hapa, ninge right click kama nilivyofanya hapa. It's okay. So what's our output? Our output is alarm, like that. Okay, so after we have it like that, then we can monitor it and see how it reacts. Okay, let me draw this down again. Okay, down again. Right, yeah, so I see the whole block. So umeona, if any of this is active, the alarm will sound. Kama kuna overheat imetokea, alarm ita sound. Kama kuna gas leakage, alarm ina sound. Kama kuna unauthorized access, alarm ina sound. Lakini If you want to reset it, then yes, a reset switch should be pushed or should be pressed to reset the alarm. So let me compile this. It's compiled. Let me download to device kwa sababu nilisha start simulation earlier, then say load. Kikataa labda nita start simulation from the beginning, then tasema go online. Okay, everything is green here, everything is fine, then tasema monitor. Okay, so here we have our safety alarm system. So come here, nita reload hizi tag again, alafu nitafuta hizi tag ambazo zilikuwa previously, hizi za mwanzo. Hapa overheat, okay, I think it's fine. It's fine. So let me try to switch on overheat. So you see if there is an overheat, then alarm is on. Hata ukirelease, hata kukiwa hakuna tena signal ya overheat hapo, ukiona hata kama ikiwa no overheating, still alarm itakuwa on unless you press the reset switch. So ukija hapa ukipress the reset alarm switch, if you switch it like this, then the alarm goes off. Let's say there's an authorized access. So unauthorized access, let's say it's true, there's an authorized access. All right. So the reset switch should be released. Why is the reset switch here? Yes. So the reset switch should be released. And then if there's an authorized access, then the alarm goes on. Okay. Yeah. So I hope you have captured this one. You have understood it so well. Yeah, you're doing great. Unaweza ukafikiria pia other minor simple projects ambazo unaweza ukaendelea kuzifanya, and I know for sure you're going to master this PLC programming so well. Okay, so until the next lesson, this is it for now. Keep moving forward. Ciao.